Okay. So everybody knows that if you're changing the data path, it would be good to have some quick tests to see if you're not actually changing anything in your data path and making it slower. I was in the same situation a while ago, and I couldn't find a solution to actually do that quickly and easily without having to change my setup or having a script that actually messed up my setup and everything wasn't okay. I needed some graphs and some other stuff to quickly see what was going on when I changed something. I needed to work with my tester that I had at the time, a Xena tester. So I decided to write my own script to do that, and it's been very useful. So I've been modifying it a little bit to make it more general, useful for this solution. The script will test 3 topologies, so the well-known PVP topology, but on a single NIC interface. So it will go in the same NIC, and it will come out of the same NIC, both on the virtual machine and the non-virtual machine. It also has support for physical to virtual, so only up, and that's it. There is a port-to-port test, so if you don't care about the virtual part of it, you can do that too. The script has a virtual-to-virtual setup as well, but that was using a proprietary setup, so that's commented out, but you can still look at it and maybe change it if you want to. So the traffic is generated at line speed by default, so if you have a 40 gig NIC, it will send 40 gig of traffic, but you can configure it to be lower. The thing I found really useful, I added recently, is a zero loss test, so it will start at like 50% of the traffic rate, and then will slowly go down or up depending if you're dropping packets or not. When you do configure it up, you can give it a set of streams that you would like to have, so a number of streams, and it will try each packet size for that specific stream, and then generate the graph and test results based on that. So the traffic generated by the traffic generator is currently Ethernet, IPv4, and UDP on top of that, and it has 3 ways of changing the packet when it's sent. So you can either do a full layer 2, so it will change the MAC address, layer 3, so it will change the IPv4 address, or you can do UDP port changes. Currently, it only changes 2 tuples out of the 5 when it's doing the change. That was a limitation in TRX at Xena at the time. So I haven't changed that yet, but I've looked at the EMC distribution, the PMD distribution, and it seems to be even out nicely. So I didn't go any further than that. From a configuration perspective, so it doesn't touch or it doesn't have to touch any of the bridge configuration in your setup, which is useful, so you can set it up as you like it and it doesn't change anything. The only thing it does do for you is it creates the flows, the open flow rules. Currently there's 4 options, which is what the default one is flow, so it will create a /32 or a full mask flow in each direction. So if you test, let's say, with 10 flows, you will get 20 open flow rules, 1 to the virtual machine and 1 back. You can also use a normal, so it will just program a normal rule for you, and you will have bridge learning in that scenario. There is a port option, so it will create a static rule, go input port to egress port, and that's it. And then there is none, which basically is don't touch anything. So if you like to, configure some complex rules in that scenario, you can just take that option, and it won't touch your config. This is the explanation. So how do you run it? It's a separate script. You can either run it on the DUT or on your laptop, whatever you like. It will just connect through the DUT through SSH. It will also configure it will not configure, but it will connect to the virtual machine and start test PMD with the specific options you need. This is an example of a command line. I just put everything in the presentation, so it's a nice reference, but I'll skip it quickly. The results that you get is like a CSV file with the packets sent, the ratios of it, so you can generate the graph afterwards if you want to. The script will also generate the graph for you. So this is the result for a graph for a specific number of streams. The top one is the graph for the packets per second. The red one is a graph on the utilization of the actual link. And then the 3 graphs below are CPU utilization. So the first one is the PMDs and GAST. The second one is all the different threads for OVS itself. And then the bottom one is the one for the remaining CPU. So basically, it's the Linux type CPU division. There's graphs for total number of ones. And there is a graph for 0 packet loss, so it shows you how many packets per second we're actually sending out. And that's it. Thank you.